Hello everyone.
Hello, sir.
How are you?
Very good.
So how is going your preparation? Hi Dinesh, Saket, Sunil. So are you preparing for interview or have just gave the written?
So basically, I'm preparing for the synergy.
Oh, okay. So let's start. What is NDT?
Non-destructive testing.
No, like definition.
So NDT is the process of testing of material without harming the product that we are testing.
Yeah. So like what we test there with NDT?
So we test the uh, cracks or the if there any pores in our final product. It is mostly used in a welded product. So means if we weld two parts, so we have to check if there are some cracks or pores. So for that we use the NDT method.
Hmm. Anyone? Other? Saket, Sunil, Viswa. Hi Yadav. You are muted. You are muted. Unmute yourself.
Okay, done.
Yeah. What is NDT?
Hello.
Yeah. What is NDT?
NDT matlab? Sorry, I cannot understand what you are saying.
What is NDT? Non-destructive test.
And did actually I have joined today only first. This is my first class.
Oh, okay, okay. So anyone know other than Wagle? What is
Okay.
NDT?
Yeah, bro. NDT is non-destructive test. It tests the material without damaging the materials.
Yeah, okay. NDT is a non-destructive test that is used to find the cracks, defect, damages, and the dimension of the component without damaging it. So we do not only find cracks or weldings, we can find also dimension also. Okay. So this is the definition of NDT. So how many types of NDT? What are the types of NDT method?
Bro, but I don't know. Surely there are many types, but I know liquid penetrant test, magnetic particle test, and these types only I know.
Anyone? If you
So visual inspection, then ultrasonic NDT we can use. Then ED current NDT we can use. Uh, then
Yadav, you can mute yourself if you are not saying anything. Yeah, continue, Agle.
dry penetration or liquid penetration testing.
Yeah.
That's what that much I know.
So first is visual, okay, and second is dye penetrate, and third is magnetic particle NDT, and ultrasonic NDT, and eddy current NDT, and radiography NDT. These are the NDT we use. So today we will discuss dye penetrate, magnetic, ultrasonic, and eddy current NDT. So what is visual NDT?
So visual entity is nothing but we see the product, and by seeing that from our naked eye, if there are some cracks or holes, we can detect it.
Yeah, NDT visual means naked eyes we use. So okay, next is what is dye penetrate NDT?
We use a dye that penetrates into the metal surface, and then we can usually see it after it's penetrated into the defect.
Okay, I will explain with picture. Now I'm going to share my screen. Is it visible to everyone?
Yes.
So in dye penetrate, we use three spray. Okay, first is cleaner, second is penetrate, and third is developer. So we will discuss how we do it. So this is the method. Okay, so if we have some workpiece and we want to find the cracks there, so what we do, first we clean the surface. Okay, wait 1 minute. Okay, yeah. So what we do, first we clean the surface. So we clean the surface to remove dust, grease, oil, and all other things before start. Okay, so that may give you the clear visual. So what we use cleaner there. Okay, we spray cleaner on it and we clean with the cloths the surface, this surface. Okay, second step, what we do, we use penetrate which is red in color. Okay, so we spray penetrate on the surface here, like here is sprayed. Okay, so after we leave it for 5 minutes, that it can go deep down easily. So we will wait 5 minutes there, and after that what we do, we again take a cloth and clean the surface, the extra penetrate. Okay, in uni motion, not in to and fro. One way we remove. We do not want to clean all the penetrate, just the surface, the extra penetrate. After that, we use developer. Okay, we spread developer on the surface. Here you can see that, which is white in color. Why we spray white in color? Because the red will be easily visible. So what happens after a few minutes, the red will come, the red penetrate, just come on the surface easily. Okay, so in this way we can find the cracks. So here we can remember three things. First step cleaner, then penetrate, then developer. Penetrate is red in color and developer is white in color. Okay. And the second is magnetic particles. First one is clear to all.
Yeah, bro. Yeah, bro.
Okay. Second, we have another method which is magnetic particle. In magnetic particles, we have this we use this, which name is, its name is yoke, Y-O-K-E, yoke. Uh, it magnetizes the surface. Okay. Thus here is same. First, we clean the surface to remove the dust, oil, grease, and everything. Then what we do, we use this yoke. Okay, we use this yoke to magnetize the surface. Look, take this example. This is a surface. First we clean it, and then we use yoke which is this one, to magnetize. So we can magnetize horizontally and vertically both, but the best is 45 degree. So in 45 degree it covers more surface. Okay. So here we use magnetic particles. We use two types of magnetic particles. First is wet. Wet means we dip into the water, and the second is dry, just like a powder, just powder. Okay. So what we do when we magnetic, 1 minute. Like for example, this is our surface. Okay. So we have to magnet. This is a surface, and we want to magnetize. Okay. So what we do, first we clean and we use yoke in a 45 degree. We can do horizontally, vertically and horizontally both, but 45 degree is best. So when we are doing when we are magnetize this specimen, so at the same time we use spray the magnet, we use powder, we use the dry magnetic particles spray on it. Okay. So or sometimes we use wet also. So when we spray, so it the because of magnetic field, it takes the the what we call magnetic field. uh, in this way magnetic field it started. Okay. So if there any cracks, it will accumulate on that cracks, it will accumulate on that cracks. So in this way we use magnetic particles to visualize, and after that we use air or syringe to spray out all the extra magnetic particles. Okay. So this, see the screen. Okay. So we use these things to remove extra magnetic particles if we put it there. Okay. And this is a pi gauge. uh, this is not very in use. If you want, like you can see here is the cracks. Okay. In this way this is the cracks. So if you put magnetic particles over this, and if you magnetize, and after that you can see that the magnetic particles will fill into this line. Okay. In this line magnetic particles will fill into in this line, and the extra magnetic particles will remove by with this equipment. Just the air, it gives you air. So all the extra magnetic particles will remove from this surface, and because of cracks in this, it will accumulate in this area, in this line. So this is equipment pi gauge you can use before start, so you can say that it's work or not. Okay. Is it did you got it what I said? The second magnetic particle, have you got?
Bro,
Hello.
once again repeat the function of pi gauge only, bro.
Pi gauge pi gauge is not used while we do NDT. Okay. So it's just a equipment. We can see that our equipment is working or not clearly. Okay. So if we take this pi gauge as a specimen where we have to do NDT on it. Okay. So it just give you the examples. I am giving you the examples. If there are any cracks in it, so it will fill in this line. Okay. If there are any cracks in it, it will fill in this line, magnetic particles, and extra will remove. It's not a part of NDT. It's equipment. Got it?
Yeah, bro. Yeah, bro.
Okay. Look, this is the magnetic particle NDT. So here he is cleaning the surface, then magnetize 45 degree, then spray magnetic particles, and here is also a magnetic particles is spraying and removing the extra on this surface, and there is a line that is used to find the cracks there or the holes because of weldings. Okay, so you can see that if there any welds that not proper welds, it will accumulate in this area. Otherwise it will not accumulate here because of magnetization. So is it clear, or shall we move to next?
Bro, why it is used at 45 degree only?
45 degree is the best. If you do horizontally, for example, if you do horizontally and vertically, so it's good. But if you do 45 degree in this way, so it will cover more area. Okay, it will cover more area like 45 degree. This is 45 degree at 45 degree. Yeah, you can see that it cover more area. The more space area is covered while we do 45 degree, and its name is yoke. So is it clear to everyone?
Yes, bro.
Okay, so next is ultrasonic NDT. This is not eddy, it's eddy current. Here is two main components. This is producer, or we can say it. Wait one minute. Someone wants to. Okay, there is two main components. This is producer. Okay, and we call it pulsar also, and this is probe or transducer. We can say it. Probe. Its original name is probe, but we say it transducer because it transduce. So in ultrasonic entity, this pulsar gives a high voltage electric signal to the probe. Okay, and this is the specimen where we have to find the defect, damages, or dimension, whatever. So this 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 high voltage electric signal give into the probe, and because of defects and damages, if there are any defects or damages, this high voltage uh, electric signal sorry so first we give a high voltage electric signal to the probe, and probe convert it into high voltage high frequency ultrasonic sound, ultrasonic waves. So if there are any cracks or damages, these ultrasonic waves return back to the uh, producer. Now it's become a receiver. Okay, first when it gives, it becomes a producer, and when it's sent to it, it become a receiver. Okay, so the again I am saying, so it gives high voltage electric signal to the probe. Probe convert it into the high frequency ultrasonic waves. If there are any cracks, it return back to the it convert back to the electric signals. Okay, to this uh, receiver. So in this way, we can find cracks and damages. So it's very easy. Is it clear? Is it
Yeah,
clear?
bro.
Okay. Next is eddy current. Eddy current NDT. It is same like ultrasonic. It's a eddy current NDT. So here is also a receiver. I will this original picture. So this is eddy current. Okay. So this is a receiver, or it's a holder in and we can say it's probe also. So what is a, this is a holder and this is a receiver. So first we give AC current, okay, alternating current generate here, and this is a specimen or the workpiece where we have to find the cracks damages. So when we give AC current, it generates alternating magnetic fields, and this alternating magnetic field move in this way because of magnetic fields. And when we touch this holder to the specimens, here it generates eddy current. Okay, so if any disturbance in circulating of eddy current, any disturbance in circulating of eddy currents because of cracks and defects can be observed by the receiver here, can be observed by the receiver here. Okay, you can see that how eddy current works. First we give alternating current, it generates magnetic fields. Okay, and now here it generates secondary magnetic fields because of the workpiece, and it induces the NDT current, AD current. So if there are any defects, the signal goes to the receiver, which this is the receiver. Okay, very easy. And this is a practical image. They are doing the NDT here. This is also the another picture, the alternating current giving to by the holder, and the primary magnetic field, and this is the secondary magnetic fields. There is a cracks. If there are any cracks and disturbing in eddy currents, it will observed by the receiver. So if you have question, you can ask. I done.
Bro, can you repeat this eddy current once? Please. Principle, basic principle.
Basic principle. Right. I will show you that image again, so you will understand easily. We have two main components, receiver and holders. Receiver gives AC current to the holder. So holder generate magnetic fields. Okay, so you if you have learned the Faraday's law, you will understand the how what is magnetic fields when the current generate. Okay, so this is a workpiece which we have to find the cracks there. So when we put this holder to that components, the eddy current will generate. Okay, so how it find the cracks, the eddy current is generating. Okay, in this way, in circular way. So if there any cracks or damages. Okay, so if there are any cracks, it will disturb the circulating of eddy current. Okay, it will disturb here. If there are any cracks, if there is no cracks, it will move in this way, eddy current. If there are any cracks, it will disturb the circulation of eddy currents. If it will disturb, the receiver will observe the cracks. So it's if you will do na by practically, so you will understand how graph has changes. We can see that graph. This is a graph. So if there are any cracks, it will start in this way. You know, waves start becoming. Is it clear now?
Yes.
Okay. So I have done with NDT. So if you have questions, anyone, you
Bro,
can ask again.
yeah. So I have a question. So could I ask?
Yeah, yeah, you can.
So bro, like the crack, like why the crack happens like in the material? Could you tell me? Like,
Cracks, like if something how something cracks, if there any, if something we hit on it, struck on it, or it will broke down, or while working, if there any kinds of incident or accident little would happen. For example, if I will give you the boiler examples, so if there we have to find inside the boiler pipeline, so lots of things can happen inside the boiler. So hammering can happen. So if the hammering happens, so maybe the chances of cracks will happen. Huh. So or
okay, got it.
yeah, we we can do underwater NDT, ultrasonic NDT. We can do underwater also if the ship is struck a little bit, stuck something there. So if we have think that maybe there is a crack or damages, so we can go underwater and use ultrasonic NDT there. So it will work underwater also.
Okay,
Or dimension, we can find dimensions, and even on civil lines, they do NDT to find the concrete. They have the sub standards, so they use NDT also to find is it the to check the quality, not only to find the cracks, used to find the the quality and dimensions also, the component dimension. Anyone have question? No? If no, so shall we go? Hello.
Yes, we can.
Okay. So today's session has ended. We will meet in another session with new topic. So bye for now, everyone.